Why is that okay? Because I went out of my way to say, would this be okay? No. Why is this okay? Because the negative isn't part of the radicand. Irrational. So what's your guess? Slightly greater than 5, yes? 5.1 would be fine. Sure. Is 5.2 slightly greater than 5?
Yes.
Then yes. What's this? Rational? Of course. What is it? 3/10. Rational? No, of course not, because 48 does not have a square root, but that is awfully close to 225 over 49, which would be 15 over 7 for your guess. What about that one? 0.5, absolutely correct. What about that one? 1/5, absolutely correct. This is the one I told everybody should go home and find out. Is 0 a perfect square?
Arguable, undetermined.
Well, I guess we're leaving that for 4 more days to see if anybody will find out. 45, rational or irrational? Irrational. So what must your guess be? Slightly more or less than? Slightly less than 7. So your guess is less than 7. What about this one? Yeah, exactly. Negative. Guess less than 7. 121? 11? This one, a lot of people look at and say it's irrational. But of course it's not, is it? Because isn't that 1/4? And isn't that 1/2? Yeah. How many people wrote irrational because they saw 5 and 20 and didn't simplify? Be honest. Thank you. Thank you. Bonus points for honesty. Gummy bear for each of you. Oh, imagine honesty getting you rewarded. Now look how many hands go up.
What if you got it right?
I didn't care about that. I asked how many people honestly didn't. And being an honors class, a bunch of people did it but wouldn't have put their hand up.
That's true.
I know it's true. That's why I'm rewarding the 2 people that did it wrong and put their hand up. I'm looking at all the people erasing right now, which is proof none of them put their hand up, which is more proof that honesty should be rewarded because the majority of the class that didn't have the backbone to be honest didn't get rewarded.
That's true. I'm so sad because I got it right.
I assume you're investing. And of course the square root of 8 is
2.9 about.
slightly less than 3, right? So your guess, slightly less than 3. Now on to the more difficult page. Dun, dun, dun. First one wasn't hard because we have our list of perfect cubes. Is that on it? No. So all we had to do was write irrational. I didn't even need a guess on this unit. You guessed that one? Excellent. What is it between? It's between 8 and 9. Slightly greater than 8. So greater than 8. 1728. Ooh. Yeah, but the negative doesn't count with the rational, right? So is it rational or irrational, do you think? It wasn't on your list, and I said no calculators. So you're making a guess. You think it's rational? Okay, what is it? No. That's a square root. 12 times 12 is 144. It is not 1,728. So it is not 12. Of course, it is irrational. This one, Cube root, big number, not on our list. But what is on our list? 27 times 1,000. What's the cube root of 27? What's the cube root of 1,000? 10. What's 3 times 10? 30. So the cube root of 27,000 is 30. Ooh, what about this one? I know people brought out their calculators. I know they did, because the answer is 15. What about this one? That is, because that is 729 times 100, which is 27 times 10, which is 270. What about this one? No, irrational, not enough zeros, because that is 100 times 1,000. 100 has a square root. Does 1,000?
I heard that as 10,000.
Ah, I know. Zeros matter. Cube root of 728. Now what's the answer? 12. Square root of 529? 23. Cube root of 1,000? 10. Square root of 196 over 225? 14/15. Square root of 125 doesn't exist. Irrational. And if you did a guess, your guess is slightly greater than 11. And cube root of 64? It's on our list, 4. Cube root of 0.125. Very tricky. 1/2. Yeah, because that is, of course, 125 over 1,000. The cube root of 125 is 5. The cube root of 1,000 is 10. And 5 over 10 is, of course, 1/2. Cube root of 125 over 27? 5/3. And the cube root of 102 is irrational. Of course, if you actually did it, it is between 4 and 5. Slightly less than 5? Yeah, it's quite a bit more less than 5, right? It's almost in the middle. So your guess is still less than 5. I'd be happy with that. On this page, calculate the surface area of a cube with a side length of 15. If it's a cube, what does that mean this is? 15 times 15, which is what? 225, because you memorized that from your list that I told you to memorize, right? How many sides are in a cube? 6. So what do you do with 225? Multiply by 6 to get 1350. Calculate the surface area with that volume. Well, the volume is 216. What is each side? 6, because it's the cube root of 216 and it's on your list. So that's 6 by 6. So how big is this? How many of them are there? 6. So what's the surface area? 216. Crazy! Same surface area and volume? Nuts. And yet true. Dun, dun, dun.
Possible.
No, totally possible, because I just showed you.
Possible.
This doesn't have the same ring to it. Possible.
Possible.
It wouldn't be as good if the superhero in the movie went, that's possible. Sounds kind of dumb.
Yeah. Wait, but what about when they said that just might work?
That might not work.
That might not work, impossibly so.
Sure.
That's
how
could it
I'm
work?
doing these lessons.
It's so crazy, it won't work.
All right. Let us move on to actually what to do with something like that, which isn't an estimate and isn't using your calculator. Because from now on, you're 99 times out of 100, so almost always going to eschew using your calculator when you are faced with that. What does eschew mean? No, not do it. You will not be hitting that button for this expression almost ever again. Okay? I know it hurts physically in your souls to cut the cord with your calculator in math class. I know. Do you all need a moment? Okay, take a moment.
I wore the sweatshirt
Because
before my
you're going to be letting your calculator go a lot this year. So maybe you need to talk to it a little, chill it out a bit, let it know that you still love it and you still need it, but you're going in different directions now. And it's not so much your calculator, it's you, right? It's not you, it's me. I'm getting older and I'm maturing past the need to use you. Are we all done? We've let our calculators
We
go.
can't do it on Valentine's Day.
Your calculator is already writing, oh hell, which is 0.7734.
Isn't this kind of cool to do this on Valentine's Day?
Well, let's just think for a second here. Do you think I'm writing this comic bit in my head about breaking up with your calculator on February 13th because we're not going to be here on February 14th? Huh? That's just so crazy it might not be impossible.
Whoa.
Possible.
Wait.
That's possible. Because I write all my comedy as I am saying it.
Of course. Nothing's pre-prepared.
No. Well, you think I lie around at home with a notepad? Oh, this is a good one to use in math class tomorrow.
Well, it's either that or write down with a notepad and do equations.
Yes, when I go home and hang upside down in my bat cave,
Yeah.
I am doing math equations on a small notepad. And when I run out of math equations, I am indeed writing my material for the next day.
Doesn't that not make that makes sense? No, it doesn't. What did you do at home?
All right.
What?
So you're going to learn what to do with this now. But before
You make them up on the spot. Never pre-prepared.
Before we go ahead, we must be aware of all the terminology that we are going to be using. So over here, you are going to write the following expression only with variables. Y, square root, put an X there, and put a little n there. You already know what all of those things are. What is the proper word for X? Radicand. The radicand is what we are going to simplify. And when we simplify in math, that basically means we make the numbers smaller, right? If I wrote 12/16 and I said simplify it, you would of course write 3/4. And the numbers are smaller, even though the value is exactly the same. Is everybody comfortable with this? All right. Then there's this number, which you already know as well. What is that? That is the index. And we've talked about that. That is the size of the group of factors that you seek. If there's no number there, you are looking for groups of 2. What do I mean by that? Square root of 4 is the square root of 2 times 2. There's a group of 2. Everybody good? Excellent. And thirdly, there is the y there, which is a coefficient. And what does a coefficient do always in math class? Multiplies the thing that's right beside it. Not like an exponent, just regular multiplication. That multiplies. Okay? I'm going to be using those 3 words. I'm going to be using index, coefficient, and radicand all through this lesson. You have to be comfortable with what the 3 are, yeah? Okay. Now, simplifying radicals. A radical is any, and I've already written this definition, expression. Why am I using the word expression? Gideon.
Because that can include the entire
Yes.
question rather than
Yeah.
just a single.
It's not necessarily just a number. Okay? Any expression using that symbol anywhere in it. Okay? There are 2 types of radicals. There is an entire radical. What does the word entire mean in English? Whole. An entire radical is just a radicand. So it's this. Square, a root sign, a radical sign, and a radicand. That's it. A mixed radical, and it shouldn't have been crossed out, it should have been highlighted. A mixed radical is a coefficient and a radicand. This is usually our goal. We want to get to a mixed radical. Everybody good? All right. Let us begin with how to do this. And remember, what I am about to show you is the way you are going to deal with all irrational numbers from here on. Okay? 72. We already know, we guess it was 8.48. We've got that. We know how to do that, right? How we do this here is we break this down. Now remember, when we broke down 27 and 1,000 to get 27,000, we saw what to do, right? When we listed all the first 20 squares, you could see that if I combined the square root of 4 and the square root of 100, I got the square root of 400, which was the square root of 4 times the square root of 100, 4 times 10, or 2 times 10, 20. Yes? That is what we do. To convert these, your first step is to break down the radicand. How do we break down the radicand? Into prime factors. Now, we have already done that using the factor trees. Take 72 and break it down. Now, I know that you're all going to choose the obvious first two branches of 24 and 3. Right?
No.
Of course not. You're all going to choose 18 and 4.
No.
You're all going to choose 12 and 6.
No.
Some of you will have. Most of you will choose 8 and 9. And will it matter? Of course not. So you will break it down however you see fit. I am going to be contrary and do 24 and 3. That's a prime number, so I stop. I carry on with 24, 3 and 8. That's a prime number, so I stop. 2 and 4, that's a prime number, so I stop. 2 and 2. And now I know that the root of, and I will change color because I'm going to drift over under my black ink here. The root of 72 is also equals the root of 2 cubed times 3 squared. Does everyone see that?
Yes.
2 times 2 times 2, 2 cubed. 3 times 3, 3 squared. 2 times 3, or 2 cubed is 8. 3 squared is 9. 8 times 9 is 72. Is everybody comfortable to here? Excellent. What is the index number that we don't write but should be there? 2. Indices tell us the group of factors that we seek, yes? Is there a group of 2 that I can get out of there? Yes. How many groups of 2 can I remove from a group of 3? I can remove one group of 2, yes? And I will be left with one remaining 2, yes? So I can take out a single 2, 2 to the 1, right? Okay. Can I remove a group of 2 from the 3s? How many? One group, 3, yes? What did I leave under there? What did I leave under there? What did I leave under there?
Under who?
Thank you. What did I leave there? What did I leave?
2 squared.
Not 2 squared.
Nothing. No.
Okay.
Well, number 2.
Right, I left a single 2 because I was only able to remove one group of 2 and I left one remaining 2. Now I have put 2 numbers out in front. What are the 2 numbers out in front? Coefficients. What do coefficients do? Multiply. So what is this? 6 root 2. That is the answer to that from now on. What? Because, and I will show you this over here because you all said you understood, but I should have known you were lying. 2 cubed times 3 squared, yes? And there's a little 2 there, so I'm looking for groups of 2, yeah? How do I really write 2 cubed? 2 times 2 times 2, yes? How do I really write 3 squared? 3 times 3. Is there a group of 2? So out comes 2. Is there a group of 2? So out comes 3. What is left? A single 2. 6 root 2. Now I'm going to ask again because everybody, when I said there was a remaining 2, you're like, oh yeah. Now I'll ask again. Does everybody see?
Yes.
Okay. Now, yes, Lala.
What if there's more than one group of like a number? So
We just had more than one group of a number. We had 2. You mean what if there was another couple of 2s there?
yeah.
Well, we'll get to that. Relax. Don't give me away. Now, all of you attempt just A and B. Do not do C and D. I do not care that you feel you know how to do it. Just do A and B. Go. And when you're done, get up and dance a jig. I'm just kidding. You don't have to. What? What? That's coffee still. It's the morning. Durr. Tea is an afternoon drink. Positive. Yeah, but in England, they have high tea at what time? 4 p.m. 4 o'clock. Tea is an afternoon drink.
Well, anyway, cheers. So you have English lunch tea instead?
All right. 99 is the Radicand. Yes? So that's what we need to break down. What is your first step? Of course you did 9 and 11. Is 9 a prime number? No, so we break it down again. 3 and 3. So the square root of 99 is the same as the square root of 3 squared times 11. Yes? Is there a group of 2? So what comes out? The 3. What stayed under there? 11. Yeah, yeah? Yeah, yeah, yeah. 75. Break it down. What is it? 5 and 15. Most people choose 5 because it ends in 5. 15 breaks down into 5 and 3. So the root of 75 is 5 squared times 3, which is 5 root 3. Everybody good?
Yes.
Now, you will notice that just like Mrs. Bad Crumble, I have started with extremely stunted factor trees. Almost like factor shrubs. Yes? Oh, wait. Factor bonsai. Bonsai trees, little mini trees from Karate Kid. Bonsai tree. Nothing. All right. The reason I have started with these tiny little factor trees is because it allows me to easily show you a shortcut. Right at that line right there, I could have written 9 times 11, yes? What is the square root of 9? So what will come out? 3. So, anytime I have a perfect square at the end of a branch, I can stop. So if I have my perfect squares memorized, it makes life significantly easier because 75 is also 25 times 3, isn't it? What is the square root of 25?
5.
So what is coming out? 5, and 3 stays there. Now, is it perfectly legitimate to draw the entire factor tree every time?
No.
Yes, it is. It will simply take you a little bit more time. Okay? But if you can see a perfect square factor here, or if this was a cube, you would want a perfect cube factor and so on, right? Then it makes life easier. Now, most of you, if I do 80, most of you are going to do 8 and 10. That would be my guess, right? But I've been doing this a little longer than you, and I know that this is 16 times 5. Why would I choose 16? It's got a perfect square. What's the square root of 16? 4. 4 root 5. And I'd be done in one step. Most of you would have gone 8 and 10. Oh, all right. 4, 2, 2, 5. Right? And then you could stop there. Right? And you would bring out a 2. Yeah? But you would also need to bring out that 2 to get the 2 times 2, 4, and leave a 5 there. Everybody with me?
You're not even making a root tree or a factor tree. It's just like a root vegetable.
Yep.
Root vegetable.
Okay.
Root.
Sure. So
I
300,
didn't even mean for it to be.
300, some of you could be clowns and go 50 times 6. But why would you? What should you break 300 into?
3 and 100.
3 and 100. Why? Because 100 is a perfect square. So what's coming out? 10. Root 3. Yeah? Okay. You do EFG. Go. And then, Lalith, I still have your question in my head. It's coming. Don't you worry. The answer to Lalith's question. What Lalith ask? Don't worry about it, because the answer is coming. Uh-huh. I can count.
That's really cool that I heard Oh, the same. I can actually count too.
All right. What should I break 63 into? 9 and 7, of course. Why can I stop there?
Because 9.
3 root 7. Done like dinner. 32. What am I going to break it into? Oh! 16 and 2. Because what's the square root of 16? 4 root 2. Now, I put this one here on purpose because kids always use 8 and 4. And then they stop because this is a perfect square and they say it's 2 root 8. But that's not right because 8 is 4 times 2. So I got to bring out another 2. 4 root 2. Yeah? Yeah. And what's 363?
3 times 121.
3 and 121, which is 11 root 3. Can everybody do the easy ones?
Yep.
Yeah? Yeah? Yeah, yeah, yeah. Yeah, yeah, yeah. Turn the page over. Now, listen, please. Sometimes you will be faced with a very complicated expression, including radicals. And sometimes you may want to reverse the simplification process. Not often, but possibly. So I need to remind you of how that works. What index should be there that isn't? 2, which means I was looking for groups of 2, yes? So if there is a single 2 out here, how many 2's had to live under there? 2 squared. So this is really the root of 5 times 2 squared, which is the root of 20. Right? What is this one going to be? The root of 29 times 7 squared, which is the root of 29 times 49, which you would do with your calculator. I don't care. The concept is that you recognize that there are 2 7 squared going under there. Everybody cool? I don't care if you can mash your calculator and get that answer. What's this one?
That's 4 times, what's 6? 36? 4 times 6, 36.
Right? And of course you know the square root of 144 is 12, right? Now look back here. What's the square root of 4? What's 6 times 2? Everybody cool? All right. Now, what do you think happens in D? Because it's not what you think it is. Everybody write me what they think the answer to D is. You should show the steps as well, but it's not a big deal if you don't. All right. Who's got the spine?
Oh, yeah.
What is it?
Many spines.
That's weird.
So -1 outside of the thing, then the radical symbol, and then the radicand is 12 times 25. I didn't bother. So 300.
Perfect, except we wouldn't write the 1, right?
Yeah.
It would be negative root 300.
I figured it would be easier to say
Okay.
-1 because
Yep.
saying
Yep.
negative
I hear you.
in the radical thing.
The mistake that a lot of people make is they try to bring this whole thing under here, which is -5 squared would be 25, right? And they tell me the answer is the root of 300. It is not, because it is negative root of 300. Everybody understand? Because you cannot get a negative to come out of there, because you can never have a negative square root in there. Everybody cool? Yes. All right, now, Lolith, your question is about to be answered. So we're just going to do some work, and you're going to see it, and you're going to be like, uh-huh. All right. What is different in 3A than the previous 8 radicals you have simplified? Ethan. It has an index of 3, which means I'm looking for a group of what?
3.
Group of 3. So when I make my factor tree, I can't stop at squares. What would I stop at? Cubes. So you might go 54 is 2 times 27, and you could stop there. Why? Because 27 is a perfect cube. What if you haven't done what Mr. Myers said to do and memorized your perfect cubes? What would you have to do now? Keep going. 3 and 9, 3 and 3. And there you would see your group of 3. It'll catch up. Don't worry. So what is the answer?
3 cube root 2.
3 cube root 2. Everybody got it? All right, well, let's look at 144. 144 square root is 12, but we don't want the square root, we want the cube root. So we take our 144 and we start breaking it down, right? I am going to go 2 and 72. Everybody okay with that? Then I'm going to go 8 and 9. And why am I now going to stop?
Because both of those are perfect cubes.
One's a perfect cube,
One's a perfect square.
and the other one we know is 3 squared, so I'm not going to get a set of 3 out of that, am I? So what am I going to do with that 8?
3 twos.
I'm going to bring out the cubed root of 8, which is 2, right? Cube root, and what did I leave under there? A 2 and a 9, which is 18.
Wow, that's
Ease.
Picking up what I'm putting down? Read my mail, mowing my lawn?
I will not do either one of them.
All right, now,
See your mail is your
Lilith, watch this. 128, what size of group am I looking for?
4.
4. So I start breaking it down. 128 ends in 8, so what can I automatically divide it by? 2. 2, 64. 64 ends in 4, so what can I automatically divide it by? 2. 32. 32 ends in 2, so what can I automatically divide it by? 2. 16. Now I get to stop at 16. Why?
You know what happens.
It's a perfect.
Because I know 16 has a 4th root. Because I've gone one step beyond memorizing perfect squares and cubes. I have made sure that I have memorized the 2 exponents. Because you have noticed how prevalent 2 is, yes? It is a very powerful number in simplifying. So I have memorized 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7th, 2 to the 8th, 2 to the 9th, and 2 to the 10th, just in case. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Now, it's not for applause. It's just something I have done to make my math life easier. Do I need to have done it? No. Because, of course, you know you would just keep on with the 2s, yes?
Isn't it not necessary to memorize that because it's just 2 squared times 2?
Of course it's not necessary. It just makes my factoring easier. Because what I would do here is I would go 16 times 8. And 16 has a 4th root. 2, 4th root, 8. And I'd be done. Now, Lilith was saying, what if the group gets bigger? Because is not this going to be 2 to the 4th more, right? So it would be 2 to the 7th, yeah? So I can get out how big a group? 1, right? So 2. And I left under there 2 cubed, which is 8, right? Because what I had there was 2 times 2 times 2 times 2 times 2 times 2, 2, 3, 4, 5, 6, 7, right? And there is my group of 4 that were to come out. Now, Lilith, when he asked, we were still doing a square root, yes? So I would bring out 1 2, 2 2s, 3 2s, 8, and I would leave a single 2. Okay? Yeah? Yeah. So you people try D. You've got to break down 162. If you know what you're doing and you think about your numbers, you only need the first branch. Well, the first 2 branches.
I got it.
What is your first branch?
My first branch is 162,
2 and 81, and you get to stop there. Why?
because it goes 9 and 9, and 3, 3.
9 and 9, 3, 3, 3, 3, right?
And then your only thing that's left out is 2, so it's 3, and then cube root.
4th root,
The 4th root, sorry, 2.
2. Everybody good? Now let's say you didn't see that. No big deal. 9, 9, 3, 3, 3, 3. Oh, there's my group of 4. Good? Yeah? Okay. 108, cube root, can be done on the first branch if you think about it. Is it a big deal if you don't get it on the first branch? Of course not, because then you just continue going until you have it. Can anybody get it on the first branch? You have it? What is it? 27 and 4. Cube root of 27 is 3. Cube root, what did I leave there? 4. Now, don't make the mistake that kids always make when they see 4 under a radical sign and tell me it is 2. Is it? No, because the cubed root of 4 is not 2, but the square root of 4 is 2. So don't be fooled. Check your indices, which is exactly why I changed the index. What's this one? You can also get it on the first branch if you think about it. Now we get to this argument. Is it worth taking all the extra time to think about how to do it on the first branch if I'm not so hot at multiplying? Or should I just make the factor tree? What's going to take longer? Do you hear what I'm saying? Right? Like maybe I can't figure that in the first branch, so don't. Just make more branches. Most of you, I'm guessing, will go 12 and 9, because you know your 12 times table, right? And you'll all stop there because you'll see the 9, and you'll tell me it's 3 root 12. Is that okay?
No.
Of course not. Why?
It's wrong.
Well,
Because
It's also not.
isn't that 4 times 3?
Yeah.
So what has to come out of there? A 2, so it's 6 root 3, yes? Now to do it on the first branch, if you were thinking about it, you would have gone 36 times 3, because there's a square root. And you would bring out the 6 and leave the 3. But like I say, don't waste your time trying to find that magic combination if you're not super hot at multiplying in your head. Do you understand what I'm saying? Just make the factor tree. Then you cannot go wrong. I know that you're all in the pre-dip class and you want to be like, oh, I want to know. Who cares? Do the whole tree and get it right, rather than spend 5 minutes trying to figure out the exact way to do it in one to impress yourself and then have it wrong. Picking up what I'm putting down? Not reading my mail? Not mowing my lawn? You should. I pay well. Now, oh, there's my favorite font.
What?
Cocktail Bubbly.
Wait.
Pardon?
That's the name of that font. Cocktail Bubbly.
What does it look like when it's like italicized?
I don't know, probably leaned over slightly because the Italians were into the cocktails, so they're leaned over. All right, now, listen please. I know we have already discussed many times about where math goes south for people. The first time it goes south is when you learn that there is infinity between 0 and 1. That's the first time, because that opens the door to fractions. And we all know that fractions cause us to lose all control of every system in our body, because fractions, for some reason, are the equivalent of the Black Plague in the 1350s to you people. Because if I say, do these fraction questions without a calculator, you are literally quivering piles of crying babies. It's nothing personal. Everybody sucks at fractions. You could ask the year 2 IBs, and they'll be like, what's the hardest thing in math? They'll say, fractions. I don't know why, but it is true every single year. The next thing that messes you up is when the alphabet is introduced to math. Man, numbers were hard enough. Why are there letters? However, you are not unintelligent, because you are all aware that 2 squared means 2 times 2, and that would be a group of 2, yes? What does x squared mean? x times x, which would be a group of 2. So, if there was no x squared there, would you know what to do with that? We've already done that exact question. It is 16 times 2, yes? What would come out? 4. What would stay in? 2. But there is an x squared there. Can I get out a group of 2? So what would come out? The x. Would you leave anything there? No. So the answer is 4x root 2. Yeah? Just following the same logic that you would apply to numbers, right? So let us look, cabbages, at this one. What's different? There's an index of 3, so I'm looking for groups of 3, and I've got another variable. So how do I approach all questions in math when I am not sure? I do what I know first. I know what to do with the cubed root of 48. That's 8 times 6. Why did I choose 8 times 6? Because 8 is a perfect cube. So what will come out? 2. What will stay in? 6. Now, how many groups of 3 will I take out of 7? 2 groups. So I will bring out x squared. Because I will bring out one x and then a second x. But we don't write x times x. What do we write? X squared. Did I leave any x's under there? 1. Do I write x to the 1? No. How many groups of 3 can I get out of that? 1. And how many y's will be left? 2. And that is the answer to that. Okay? Now the shortcut is 7 divided by 3 is 2 with 1 remainder. 5 divided by 3 is 1 with 2 remainder. But let's pretend you don't see that pattern. That's okay because you know that this means 1, 2, 3, 4, 5, 6, 7. Right? There's a group of 3. There's a group of 3. I left 1. You know this means y. There's a group of 3, and you left 2. Does seeing the shortcuts and the patterns mean you are better at math? No. Does knowing this concept mean you know math? Yes. Okay? So what if I gave you, and you don't need to write this down, I just want to see if you can handle it. 96 x to the 5th, y to the 4th, z cubed, and I want the 4th root of that. Could you do it? Of course you could. Because 96 is 16 times 6. So what would come out? No. 2, because I want the 4th root. How many can come out of there? 1. How many stayed in there? 1. How many can come out of there? 1. How many stayed in there? None. How many can come out of there? None. So it stays in there. And the 6. 4th root. Good? Excellent. We've already done this. What's changed? We had a coefficient. There's an index. Right. So if the index is 3 and there's a single 3 out here, how many 3s are there? 3 of them. So it's the cubed root of 4 times 3 cubed, which is the cubed root of 108. Right? What's this one going to be? 5 times 6 to the 4th, which is 6 6,480. I think. 6 to the 4th is 1296. 5 times 1200 is 6,000. 5 times 90 is 450. 5 times 6 is 30. Yes, 6,480. And this one is what? 7 times 5 cubed, which is 7 times 125, which is 875. Cube root. Is everybody good? Now, I need to call your attention to a few things. Was I able to get a group out? So did it change? No. If that happens once in math, how often does it happen? Always. For example, the square root of 15. Square root of what? What do you do with the radicand every time I ask you for a square root? We've just done it 1,000 times. What do? You break it down into 5 times 3, yes? Any pairs? So is anything coming out? Okay, so let me ask you this. You borrow $15 from me. You forget. 6 months later, you come back and say, hey, Myers, I borrowed some money from you. How much do I owe you? And I say, you owe me 3 times $5. Or I say, you owe me $15. Which one is better? 15. So this stays like that. Because even though those numbers are smaller, it is simpler just to say 15. Everybody cool? Okay. Then what if I gave you something like this? I have to think of numbers that will work. Give me a moment. The square root of square root of 584. You would break that down, yes? If you broke that down, you would find 144 times 4 is, oh wait, is it? Yeah, I think it is. 400, let's see. Yeah. Oh, I'm sorry, 576. Sorry about that. You would break it down to that, yes? What's the square root of 144? 12. What's the square root of 4? 2. Did you leave anything under there? So what's the answer to square root of 576? 24, with nothing left under there, so it's just 24. Everybody cool? Great. Your job is the rest of page 40, 41, and 42. You've got 4 days, and you've got how much now? I can't even remember when this block ends. Oh, damn. Well, so it goes. Most of these are one-steppers. And of course, on page 42, need you do all of them? No. Of course not. Why? Because it's the same math, isn't it? If you can do 3 of them, then you can do 33 of them. Right? Because you all would never be those kids that do a whole question, go to the next question, and immediately forget everything, right? You would never say, did number 6. Did you just do number 5? Yeah. Did you read the instructions? Yeah. Are they the exact same instructions? Yeah. So should you try the exact same thing? How do I do number 6? You would never do that, would you? Of course not. Because then you would be opening yourself to a whole crap ton of mockery. That would be like saying, I'm going to go for a walk. Right, left, right.
Right. It's right. It's right.
Use your hands.
Right.
Mr. Rogers, I don't know what to do now.
Right.
Okay? You would never do that. Because you know how to walk.
I mean, wait, but then explain how we tripped still.
Huh?
Explain how we still end up tripping on
That is chaos. Every process in the universe tends towards chaos. That's why the universe is not infinite.
So wait.
Every process tends toward chaos. So every time you take a step, you are a little bit closer to chaos.
So then, therefore, if they were to do 20 questions and get stuck on 21, would that still technically count as the chaos?